Hello, I'm here to record the application of calculus. First, I will explain the application of derivatives in economics, focusing on cost functions, revenue functions, profit functions, average cost functions. I hope these examples will give you a clear understanding of the particle uses of derivatives. First, let's talk about the cost functions and the marginal cost. The cost function describes the total production cost, while marginal cost is the derivative of the cost function, representing the additional cost of producing one more unit. For example, if the cost function is Cx equal to 5x squared plus 20x plus 100, then its derivative gives the marginal cost MC equal to 10x plus 20. When the production is x equal to 5, the marginal cost is 70. This means the cost of producing the 6th unit is 70. Next, we have revenue functions and marginal revenue. The revenue function describes total revenue, and marginal revenue is the derivative of the revenue function, representing the additional income from selling one more unit. For example, if the revenue function is Rx equal to 200x minus x squared, its derivative is MR equal to 200 minus 2x. When sales are x equal to 50, marginal revenue is 100. This means the company earns an additional 100 for each extra product sold. Third, let's discuss profit functions and marginal profit. The profit function is the difference between revenue and cost, while marginal profit is the derivative of the product function, representing the additional profit from producing one more unit. For example, if Px equal to Rx minus Cx equal to minus 6x squared plus 108x minus 100. Taking the derivative, marginal profit is MP equal to 180 minus 12x. When x equal to 10, MP equal to 60, meaning producing one more unit adds 60 to the profit. Let's look at the average cost functions. Average cost represents the cost per unit of production and is calculated by dividing the total cost function by production. The derivative of the average cost function helps analyze production efficiently. For example, if Cx equal to 5x squared plus 20x plus 100, then ACX equal to Cx over x, which is 5x plus 20 plus 100 over x. Taking the derivative, we get ACX over dx equal to 5 minus 100 over x squared. When x equal to 10, the rate of decreasing in average cost is 4. Through these examples, we can see how derivatives help business optimize decisions in production, pricing, and profit maximization. I hope this presentation helps you better understand these concepts. Next, I will explain the washer method, a technique for finding the volume of a solid of revolution. The washer method applies when the region being rotated is bounded by two curves. For example, let's consider the region between y equal to x and y equal to square root of x rotated about the x-axis. The outer radius R1x is the distance from the x-axis to the outer curve, which is at y equal to square root of x. The inner radius R2x is the distance from the x-axis to the inner curve, which is y equal to x. Next, write the formula. The volume is calculated as this formula. We can see from the paragraph that the bounds are x equal to 0 and x equal to 1, substituting Rx and Rx. Then we can solving the integral gives the volume of the solid. Now let's talk about moments and the center of mass, which are essential in physics and engineering. First, we find the basic definition. A point on which a thin plate of any given shape balances is called the center of mass of a plate. The product of the mass m of a particle and its directed distance from a point is called the moment of the particle with respect to that point. A moment measures the tendency of a force to rotate an object about a point. For a system of particles, the moment about the region is moment x equal to the sum of mi/yi and the moment y equal to the sum of mi/xi. Mi is the mass of the particle. Xi, yi is coordinates. The center of mass is the balance point of the system, given by like this, where m is the total mass. Here's something related to these two moments. Next, we will give the example. We will give the example. Consider two particles, M1 equal to 3 kg at 1, 2, and M2 equal to 5 kg at 3, 4. The moments are moment F equal to 3 times 2 plus 5 times 4 equal to 26, and moment Y equal to 3 times 1 plus 5 times 3 equal to 18. The total mass is m equal to 3 plus 5 equal to 8. The center of the mass is 9/4 and 13/3. And now we can find the center of mass. The Marshall method helps us calculate the volume of solids of revolution, and moments allow us to find the center of mass, critical in many applications. Thank you.